evening, everybody. How y'all doing? Yeah. Did everybody enjoy the Wizarding World of Harry Potter last night? Pretty cool stuff. That's cool how they rented it all out. Save on the line time. Well, welcome to Evolve 2016. It's the final day, and I know it's been a great conference throughout the week. I hope everybody's gathered a lot of information and picking up on a lot of stuff. So to start this day off, we have Jason Smith here, and he's going to give you guys a rundown on creating custom layouts in Xamarin.Forms. So, Jason, you got a full house. Take it away.
That's like the biggest photo of me I've ever seen. So this is going to be a very technical talk. I'm going to show you a lot of code. I'm going to do some live coding in front of you by snippets. And hopefully nothing will go wrong, but you know. We're going to be talking today about making some custom layouts. And what are custom layouts? Custom layouts are bespoke little gems that you're going to use to make your app beautiful. They are ways to make your app more performant. They're ways to make your app have a layout that you can't otherwise easily achieve. And they're going to make you unique and different. But before we get into exactly how we implement these, and let me tell you it's not that hard, we need to know some basics. And the basics is essentially how a layout works, what cycles it goes through, what the flow of the information and the code in your layout is. Never been one for fluff, so right into it. This is the invalidation cycle of a layout. So layouts go through two cycles. They go through an invalidation cycle, and they go through a layout cycle. The invalidation cycle is when something changes. The layout cycle happens immediately thereafter. And that's when we're laying it out. And that's mostly what we're going to be coding. The invalidation loop really starts when something changes. That causes an invalidate measure to be called, which follows to a chaining sequence where we go up and call invalidate measure on each of the parents. And this will, if nothing were to stop that chain, invalidate the entire layout of your application and result in more or less terrible performance. So there's some simplification I put into this slide where I ignored the fact that we sometimes don't invalidate the parent. But it's simplest to think of it always chains up. And then we queue up a delay layout so we can aggregate multiple of these things together. And that's important information because if you expect an invalidate layout call to immediately cause your layout to be called, you will be very confused when you're debugging. Oh, by the way, this is PowerPoint, and there's a beautiful animation about to come up, and I spent like 5 hours making it, so ready? Here we go. Thank you. Thank you. I know. OK, so done. That's it for animations. So after that asynchronous callback comes back, we're going to be now finally getting our layout event called. This is where we finally come in with our custom layout. So we're kind of starting off at step 6. At step 7, layout children is invoked, which is where the layout will now begin to actually position all of its children. And we'll be implementing that, and then it's going to cycle through each of the children, and there's a nice loop here. So you can see that there are 2 loops, one that goes up, one that goes down. And once we're through both loops, at that point, our layout cycle is completed. That is the layout cycle in short. That's all you need to know to understand this talk. So this talk, we're going to be producing a wrap layout. What is a wrap layout? It's a layout where you have many items kind of going side by side until you hit the end, and then you go down and you keep going, right? We've all seen these before. They're very popular on websites, for example. It's not a grid because it has a variable number of columns. There may be multiple columns, a different number of columns for each row. It's not an absolute layout. It's not a stack layout. It's its own thing. So it looks something like this. Obviously, I'm just using BoxViews as stand-ins for real views here. Because the point of this isn't packing in real views. The point of this is understanding the layout. And box views are nice and easy to understand. So this is what we're going to make during this talk. And there are a few basic components that we're going to need to actually implement. The basics of a layout are first that we're going to inherit from layout of T, in this case, layout of view in particular. There are two layout classes in Xamarin.Forms, the generic and the non-generic. The generic version has public children. In other words, a user can add and remove children from it. The non-generic version has only internal children. You can't actually publicly add children to it. So 99 times out of 100, you want the generic version. If you wanted to limit this to only allow you to pack images, for example, instead of layout of view, you would do layout of image, and the API would then be limited to just images. We're going to have to implement a couple methods. The first one we're going to implement is override the layout children method. This is going to provide our basic layout implementation. It is absolutely mandatory. You may not skip this. If you do, nothing's going to work. And it's going to be called semi-frequently. So when it comes to performance, it really matters. You know, don't do silly things. We're also going to implement onMeasure. OnMeasure is new in 2.2, so if you are not on 2.2, you're implementing onSizeRequest. They are the same method, just this one's named better. Part of the reason for the change is an internal issue. If you want to ask me why I made that change later, please feel free. It has to do with margins. OnMeasure allows your view to be nested inside of other layouts. If you don't implement this, chances are your view is going to disappear. It's not, strictly speaking, mandatory. There are ways to get around implementing it. But if you really want to do things right, you're going to have to implement it. And it's called very frequently, which means that, by and large, it's up to you to make sure that this is fast. And if you can take shortcuts in this method, this is the one to do it in. And lastly, we're going to optimize. And there are some optimization tips we want to make sure we have, and we're going to go through those. This is more or less optional, but there's quite a few things that we can do to make things a little bit faster along the way. So we're going to start by looking at layout children. And we're going to get into some code in a second, but first, there are some do's and don'ts. Layout children must call layout child into bounding region for each of its children. Technically, you can also call layout on each of the child, but this is a helper method that takes care of the vertical and horizontal options for you, so you don't have to worry about what those mean and what they are. It will just basically handle it. It additionally may call measure on any child. Excuse me, is there water? Yes, there is. It does not have to call measure on everything, though. I know some of you may have worked with toolkits before that make that mandatory. It is not mandatory in Forms. And lastly, it is allowed to lay out children outside of its own bounds. If it does so, they will just render outside the bounds. They may not actually be interactive, though. Depends on the actual underlying toolkit as to whether or not we're allowed to make something outside the bounds of the parent interactive. So be aware that anything you put outside there probably shouldn't be like a button. And then there are a couple do nots. Do not call measure on a view which is not your own child. This is a great way to get into an infinite loop. That kind of stinks. And if you call invalidate measure inside of layout children, another great way to make sure your program never actually finishes executing. So here's the basic concept of what we're going to do. We're going to override the method. We're going to loop over the children. We're going to call layout child into bounding region on each of them. And we're going to do some kind of math in between the call to layout child into bounding region to calculate exactly where it goes. That math isn't important. It's going to be special to you and your implementation, so we're going to have the wrap layout math in our example. Time for some code. All right, here's to this working. Ta-da. OK, so we have a project here. Obviously, I've primed it a little bit. We have an application, or an app.cs here. And here we have our main page just being a wrap page. Was a wrap page. It's a page we've defined in XAML. which contains a wrap layout being our custom layout. And we gave it a background color of aqua because aqua is beautiful and wonderful and all that stuff, right? Everybody loves aqua. And we've also defined a spacing just so we can show how we can use spacing parameters on this. Spacing is not default for layout. We're going to have to implement it. So currently, this code won't even compile because, it won't compile because we haven't implemented spacing. And we can see that we don't have anything being packed into this layout yet. So let's quickly look at what our layout looks like. This is the default layout. You are required to implement layout children. It is an abstract method, so when we generate our subclass here, my IDE handily filled in that method with a not implemented exception, just to make doubly sure that nothing runs. So let's go ahead and get that spacing implementation. Have any of you guys seen how to implement a bindable property by hand? Yeah, OK. So I will briefly discuss how that works. It's really simple. What you do is you come over to this little snippet here, and you double-click it. There we are. OK, really, we have this bindable property here. We make it public static read-only. That's always public static read-only, never not public static read-only. And, my font is so big that I forgot this was going to wrap. Let's do that. So we're going to use the name of operator to make sure that we pass this string correctly. And if we run any refactorings and we want to name this wrap spacing or layout spacing or whatever else, that we don't have a magic string here that isn't going to get updated by the refactoring tools. We define the type of the property, in this case a double, and the declaring type, the owner of the property, which is the wrap layout itself. We give it a default value. And in this case, we're going to handle a property change event. And what we're going to do in that property change event is simply call invalidate measure. That way, anytime the spacing of your layout changes, we will invalidate its measurement. Currently, this is run by hand. In the future, we may actually provide a way for you to specify that whenever this property changes, invalidate the measure, just so it's a little easier. After that, we have our actual bit of API that most people are used to seeing, which is the public double spacing. Looks like an auto property, not quite an auto property. Instead of having a backing store, we call get value and set value. And we pass the bindable property we just created. Straightforward, easy. Don't be afraid of making these. They're fun. This automatically will then implement iNotify property changed and work quite well. OK, let's implement layout children. So it's going to look just like this. OK, so this is going to look very similar to that slide we just saw, where we're going to just loop through all of our children and call layout child into boundary region. And there's this one bit of magic here where I call compute layout. This is where I've abstracted away all of that wrap layout logic, which is interesting to look at. But I first wanted to show you that it looks the exact same as the slide, right? We're just looping over the children, grabbing them out of the array, and calling layout on them. And what we can do is we can insert this row class here, because we're going to use it. And what a row is in a wrap layout, I mean, if we imagine everything's kind of going bit by bit by bit, it's just a list of rectangles, in this case, where each of the rectangles go. We're just storing the bounding region of where we're going to put each of the children. And then when we wrap down, we'll make a new list or a new row and store them. And we're going to have a width and a height for each row so we can know how big it was. And again, your layout may not require this kind of depth, but a wrap layout certainly does. OK. And then lastly, we have our compute layout call, which is this bad boy right here. It's a lot easier to explain this when I have a lot more context on screen at once, but 160% zoom really constrains that. And here all we're doing is really just calling compute naive layout, and we're going to use a little bit of link to flatten all those rows into a single list. So compute naive layout, we can see returns a list of rows, which means it's a list of lists, which is exactly what a wrap layout is. It's one row after the other after the other. And we're just going to call select many on it. Now, I will say that select many is it's going to initialize an enumerator. It's going to initialize some objects. If you're doing this for real and you're not up here demoing this on stage, maybe don't use the link. It's going to be a performance hit for you that you might not want to take. OK, and here's the math. Now, this is actually not that important to you. This is just math. All I'm doing is figuring out how big something is by calling measure on it. If my row count is 0, I'm going to handle my base case of basically sticking in the top left and making sure that I create the right row and everything. At which point, I'm just going to calculate where it goes on screen. Now, you may not need to calculate that. You may have specific regions that you just know where everything goes. But in our case, we're trying to make something a little more generic, so ours is just calculated, and the previous position informs where the next position is. So we just kind of track that. At a certain point, we detect, hey, we have gone wider than our width constraint, which is the value passed in to our compute naive layout, which is being passed all the way up from layout children, which is our width and our height. So we are constraining ourselves to the width or height, and in particular, the width of our layout, because we want to wrap when we go over the right edge. So we're going to wrap here, make a new row, add that row into the results, and keep on trucking, right? And then finally, we're just going to return that result. It's not that hard. This code will be up on GitHub. If it's not on my presentation because I forgot to put it there, I will tweet out a link. And yeah, let's run this and see what this looks like. Hopefully I didn't forget to do anything. Find out. This is the part of the presentation where I sit here and talk awkwardly because compiles are taking a while. What was for breakfast? I didn't get any. All right. If you're not using these Visual Studio Android emulators, by the way, you're really missing out. They're beautiful. All right. And a blue screen. Perfect. That's not what I was expecting. Oh, I know why. Yeah, it really helps if you put something in your layout when you're testing it. Because if you don't do that, what you get is that wonderful aqua and nothing else. So here all we're going to do is we're going to pack 2,000 boxes into this thing, because 2,000 is a good round number. And we're going to give them all a random color. And little fun fact from somebody who's a bit of a color nerd, if you ever want to make a pastel color in Xamarin.Forms, make any color you want, then, oop, what's going on? All right, scroll back over. Be nice, Visual Studio. Run dot with luminosity 0.8, dot with saturation 0.8. All your colors will be pastel. Then we're just going to add those 2,000 box views in there. And we're going to uncomment this bad boy right here. Save it, run it, talk awkwardly while we wait for a compile again. It was always my life dream to follow up my speech from Grant Imahara. OK. Here we go. And what we can see is, because we packed uniform-sized boxes, we have a perfect grid. And to test that we are actually properly wrapping, we can rotate the screen, and lo and behold, it changes the number of columns. So can we scroll? Well, no, we cannot scroll currently, because if we look at our page, it contains no scroll view. But there's that little commented out bit, so maybe we'll get there. So yeah, And we can also even pack some non-uniform sized boxes. So we'll do that really quick. Pack random sized boxes. So here we're just going to use the random number generator to change the width and height request of those boxes. And we can swap over here and see what this does. Am I doing on time? 20 minutes. OK. I could have picked a simpler layout to show you, but I don't think it's interesting. I don't think it's fun. I wanted to do something that was kind of useful for once. OK, so random sized boxes, we can see that this row here has 7. This row here has 6. So our wrap is working correctly. But there's a couple interesting things to note. Everything is kind of smushed to the left, and maybe we don't want that. So we can quickly fix that. There's a reason that I always call my layouts into this strategy of having a naive layout and then having that pass back the regions where everything goes. Because then you can take those regions and you can do interesting things like this. We can, for example, center them. Fairly simple. You just double click on your snippets. And hopefully Visual Studio is going to play nice. It is. Yeah, uncomment that line of code. And all we're doing is we're looping over each of the rows. And we're going to check their width. We're going to check it against the width constraint. And we're going to apply a little bit of centering to all the children within those rows, just by bumping the regions over. Nice and easy. And I'm sure you would take my word for it, but it does indeed center everything. So we'll bump back over to the slides just as soon as we prove to ourselves that we've centered everything correctly. But I want to mention that the reason when you do your own layout, you might want to consider doing the naive layout approach, where you have the simplified layout and then you modify it after the fact. And we're going to see a couple more reasons why we're going to do that in just a second. But there, everything is centered now and beautiful and wonderful and kind of a 1980s sweater. OK. Bump to slides. And of course, because I have to hit stop presentation every time, we're going to get to see that animation a couple times now. OK. Let's talk about overriding on measure. On measure is how you're going to get this thing to actually enable scrolling. And we'll show you what's going to happen if we didn't implement on measure. But it's called fairly frequently, so that's important information. If you don't implement on measure, your views may not show up. Even if it works right now, which it does, it may not work in other scenarios. And generally speaking, it's just the right thing to do. So implement on measure. There are plenty of cases where you'll implement a view and it will work just like we just had. And you'll think, great, I'm done. And you haven't done on measure. You've made a mistake. On measure must return a size request. That's the only requirement. You can hard code a size request if you really want. Don't do it, but you can. It may call measure on each of the children. It is not required to, just like the layout may call measure on each of the children. And it may also return a size request which is larger than the constraining sizes. This indicates that it is unable to properly lay out at the constraining size. This is a valid result in Xamarin.Forms. Some toolkits will consider this an invalid result, and Xamarin.Forms will yell at them. You should never call layout or layout child into bounding region in the measure calls. If you do so, you are not necessarily going to get an infinite loop. You're going to get highly undefined behavior. And lastly, you should not call invalidate measure. It's another way to get an infinite loop. This is kind of what our on measure call is going to look like. We're going to make up a size request here. We're going to loop over all the children, figure out kind of how big this layout needs to be, and then we're going to return this result. Simple concept. Back to code. Go Windows. It's doing this thing where it's switching between mirroring and extended mode. It's really interesting. I've never seen it do that. OK, measurement. I told you that if we don't implement measure, there we go, bad things will happen. So let me show you bad things. I was supposed to do that before I went back to the slides, but you know, memory and all that. Because it would still work. It wouldn't break it if I just put the wrap layout inside the scroll view. The stack layout's going to measure how tall this thing really wants to be, and then squish it as much as it can. Because that's how a stack layout's defined. It's defined as giving everything as little vertical space as it needs so it can put the next thing down and down and down. And if we don't implement measure, what we get is a gray screen because the stack layout measures it and goes 0. I haven't thought about exactly what it's going to do on its own in a scroll view, to be honest. My best guess is it's actually still going to be blank. But hey, live demos, right? Let's do it. OK. Should we start like a betting pool? Are we allowed to talk about that on the stream? I don't know. Nobody's waving at me frantically from the back yet. I typically run on a simulator until I'm performance testing. Then I'll switch over to a device. Now, I will say that on iOS, I'm much more frequently testing on device because the difference between the sim and the device is much larger than it is on Android. Because they're not running a true VM there. OK, so it still shows up. Yes, but it shows up, but I can't scroll it. Because the scroll view doesn't know how big it needs to be. And if I put it in a stack layout, it's just not going to show up at all, because the stack layout is going to squish it as much as it can. So what we're going to do is we're going to come over to our wrap layout here, which is now 100 or so lines of code, which is just spectacular. We've coded that so fast. And we're going to implement measure. Again, double-click is the way to go. Measurement calls receive a width constraint and a height constraint. Those are just the way the parent layout tells you how big it expects to be able to lay you out to. So if you're the root of a page, that's going to be the size of the page. If you're within a stack layout, it's going to probably be the width of the stack layout and the remaining height it has left to give you. And I talked about how we do our layout children by calling compute layout, which calls, in turn, compute naive layout, which doesn't do the centering math, because the centering math is not required to figure out how big the layout needs to be. So we can skip that math and call compute naive layout directly. And from there, we can figure out, OK, what's the widest row? Again, a little bit of link you shouldn't do in a real layout, but it's nice for demos. And we can find the last row, and we can grab the bottom of the row. Did I actually implement a dot bottom on rectangles? I think I did. I did. So that would be simpler code, but demo. We're not testing that. So this is all we need to do to measure. It's just coming in and figuring out, OK, for this particular width constraint and height constraint, how big do I want to be? And in the case of a scroll view, it's actually going to get a region that's infinite and infinite. And then the stack layout's going to constrain it down to its width, which is going to be the width of the scroll view. And we're going to see what this does now. And if we're lucky, everything is going to be beautiful and wonderful now. And there will be a scrolling, horrible 80s sweatshirt kind of app with pastel. By the way, if you play with those numbers instead of 0.8, you can make neons and all sorts of other fun things. OK, let's try scrolling. This is touchscreen. Whee. OK. And there are lots of these. I mean, 2,000. What if I got what? Oh, sure. Let's do that. It's going to look the exact same, I'm betting. But, you know, like I say, I give it 3 to 1 odds. No, it's going to look the same. OK. So yeah, same thing. So the last bit we're going to talk about is some optimization tips for your layouts. I've already covered some of them. Don't use link because these methods are called a lot, and those do allocations. And on mobile, allocations are expensive, very expensive. You're not running on a desktop processor. You're not using DDR4 RAM. Maybe you are on modern phones. I haven't checked. But generally speaking, you're not. It's not the fastest system you've ever worked with. So those allocations add up. Your GC pools are smaller, so it's going to happen more often. You really want to make sure that those allocations are minimal, and link is bad for that. I'm getting the yellow light, so I need to stop for questions pretty soon. The other couple things that I wanted to make sure I mentioned before we kind of go into questions here is that when we look into, where is it? Compute naive layout, you see I've copied this into this spacing bindable property into a local variable rather than access it over and over and over. That get value call that's done in that property accessor is not free. So grabbing your properties out proactively and storing them is a great way to give yourself a little bit of a boost. In the early days of Forms, we didn't do that ourselves, and there was a big performance boost when we started doing that. So you should do that for yourself as well. And like I said, that call and measure where we do, man, I've lost the layout of this app, where we use compute naive layout rather than the full compute layout pass allows us to reduce the amount of math we're doing. And anything you can do to reduce the amount of math that's happening in on-measure is a pure win for you. On-measure is going to happen between 2 and 3 times as often as the layout call itself will. OK. We're going to stop here because I want to leave some time for questions. I think if I just scroll down and click on this slide, yeah, and then hit this button. Yeah, OK. Let's do some questions. They're bringing the microphone around. I have to wait for the microphones.
Hey.
Hey, Laurent.
Are you aware of major discrepancies between the dependency property implementation on Windows and the binding properties that you guys do here? It looks very similar. Anything that comes to mind?
Well, for one, the registration methodologies are completely different. There is a concept of, the reason they call it a dependency property, I think, which is where you can have a subclass redefine what the default values are. We don't support that right now. Yeah, there are some discrepancies there. They're not perfectly matched, and I would even go so far as to say that the one in UWP is more featureful, and ours is kind of simpler and maybe even a little more efficient because of the simplicity, but obviously lacking features.
Hi, just a quick question. The wrap layout, I think it's something that's very useful. Why isn't it in Xamarin.Forms itself?
Well, then I wouldn't have had a great demo today. Yeah, that's a great question. And the answer is we just made one. So the real answer there is I'd like it to be virtualized, and I'm still trying to work out exactly how to virtualize a wrap layout cleanly, because the position of every element depends on the position of every element before it, and that math is actually a lot harder than the math we did in here, because somehow you have to like retain the position of each row and not calculate everything if you like try to scroll somehow into the middle. So you have to have like a live adaptive thing where like you detect, oh, I actually estimated wrong, and that kind of thing. And also, I didn't account for minimum size request, which is something that a real full layout implementation might want to do. And minimum size requesting in a wrap layout is a little tricky as well, because there's a lot of fuzz room you might want to use in there.
How far do you need to take it as far as the optimization goes? Like, for example, I saw in your iterator of all of your objects, you had 4 items being allocated per iteration of the collection.
Yep.
So like I could push those outside of the loop, but would you go even further to not new up rectangles and keep reusable rectangles instead of newing them up on each iteration, or how far do you take that?
Rectangles are structs, so those are all stack allocated anyway. They're not particularly, well, actually they're going into a list, so they're going to get boxed. But by and large, I would do everything I can do to reduce the amount of memory that's being allocated during the measure and layout passes. So yes, I was very liberal with memory usage in this to keep the code concise and readable. I wouldn't even do for each all the time. I would use ReSharper to turn it into a for loop. Or I don't know, Visual Studio probably has the same refactoring.
I was just kind of curious. You kept saying not to use Link, and I'm a huge fan of Link. Are there? Okay. I'm just curious. What are the techniques to avoid using it?
Well, here's what I normally do, and you can all boo me off stage for this, but I write the link, and then I hit Alt-Enter and tell ReSharper to convert it to code.
Jason, in learning to play with your layouts, the other ones, the stack layouts and so forth, I've noticed something, and hopefully you can either tell me I've done something wrong or it's something I need to look out for, and that is I realized that your on-size request event gets called more than once.
Yes.
And so I'm curious as to when you talk to optimization, do we have to concern ourselves that we may be doing the same computations a couple times, save them off? Is there
Yeah, so let me switch back over to the code. One of the things that I should do in a real implementation of this layout is, if you notice the onMeasure call, and onMeasure is almost certainly going to be called before the layout children call. I should be caching this result right here. And the reason I'm going to cache that result is, and I'm going to invalidate that cache if, for whatever reason, I need to call invalidate measure, so I can override on invalidate measure changed and invalidate that cache there. But if I cache that result as well as the width constraint and height constraint that were passed, in fact, for a wrap layout, I only need to know the width. Then when I do layout right here in compute layout, I can detect if that cache is valid and that it has the same width constraint, and I can use that cache rather than rerunning the compute. So yes, sometimes measure has to be called multiple times. We've recently added some optimizations into the core where it will not call you multiple times. It will do some automatic memoization, and that has had significant performance improvements for us. I'm not going to claim that the Xamarin.Forms layout system is as mature as things that have been around for 10, 15 years. They've had a long time to optimize.
Does it make sense sometimes to override, instead of overriding layout of the type view, overriding an existing layout like stack layout or grid layout and then tweaking it?
Yes. Now that we're open source, I'd almost recommend doing that in some cases where you go and maybe you copy in some of the layout code and tweak it the way you want. It can be a little inefficient to call the base method and then tweak the result that it produces if you can instead tweak it right in where the math is being done. So that's my only concern with doing it that way, is that there's a slight efficiency loss. And in layouts, efficiency matters. It's what determines your rotation performance, your view cell cycling performance, everything. So you really want to make sure that that layout is performant. Okay, is that it?
So how often should we actually create our own layouts? Because I feel like a lot of times we might just do it badly, and we're better to use one of the built-in ones.
So that's actually a really great question, because even though I've been talking about, like, do your own layouts and everything, and you have to care about all these performance things, when you're writing your own layout, you have contextual information that exists in your head and only in your head, and you're able to make the math much more efficient. If you're trying to compose a layout together out of grids and stack layouts, we don't really know what you're going for. So we don't know exactly what parts of the math are really required and what aren't. You might be able to short circuit and say, and the last thing is always this size, or the first thing is always this size, so I don't need to measure it. And there's a lot of opportunity in there for you to inject that custom knowledge into your layout and get better performance out of it. So often, even if you're doing something that I would say, you shouldn't do this in this talk, you're probably still coming out way ahead. And again, your layouts may not be as complicated as a wrap layout. There's one back there.
During the layout children method, I'm assuming we would also need to be concerned with the height that has been passed in, otherwise we're going to start laying outside of our bounds.
You're allowed to lay outside of your bounds if there's not enough room. So I did talk about the concept of minimum size requests, and the way you would handle this is potentially you would keep track of the minimum size of each element in each row. And if after you compute the naive layout, you go, okay, we're now too tall for that height, I'm going to proportionally reduce each of these rows until it fits on the screen down to their minimum size request. But we're not doing that in here because it was just too much to explain in 45 minutes. But essentially, that's the strategy you're supposed to take in forms. Everything has a minimum height or a minimum width. So like you'll see scroll views and list views are quite compressible. Images are compressible. Labels are compressible horizontally if they have the ability to be truncated. But not everything's compressible. I hope that answers your question there. But by the way, if there's just too much minimum, it's perfectly acceptable to flow outside. That's the normal mechanism. And then it'll either clip or not, depending on what the user specifies for that behavior.
Yeah, hi. How would you go about supporting horizontal scrolling? Or should we even try it, or should we even not try it with Xamarin.Forms?
I'm sorry, can you hold the microphone a little?
So how would you go about supporting horizontal scrolling? Like if I wanted to scroll to 2 pages or 3 pages worth, or should I not even try that with Xamarin.Forms?
I'm sorry, I'm having a hard time.
Horizontal
scrolling.
Horizontal scrolling.
Essentially, all you have to do is change this wrap layout to compute vertical columns instead of rows. And for the horizontal scroll change, we just come in here and say orientation equals horizontal. And then our wrap layout will now go for horizontal scrolling. Obviously, I'd have to change the way the math is run, but it's not a big deal. There's one more right there. We have a minute left.
Hi. Do you have any metrics around the certain limits you get to where you're like, I shouldn't be doing this in form, I should just go into a renderer?
It's going to depend. Like, if you're trying to put in thousands of views and they're not all box views, you're going to need something that's virtualized. And producing those virtualized things right now in Forms, because we haven't opened all those APIs, but we're open source now, so we're going to start having a discussion around opening those APIs, is a little difficult. So that's where you would tend to drop down and use a UI collection view and a recycler view and that kind of thing. As far as limitations are concerned, by and large, the difference in performance of similarly implemented layouts is about the same. When we measure and benchmark that, it's about within 10 to 15%. So if that 10 to 15% really matters to you. Okay, thanks a lot, guys.